Welcome to my nengi.js introduction. What's Nengi? Well, it's a scalable, high-speed, multiplayer library/engine for JavaScript games. In this video, I'll describe the main features, and then get pretty specific about how it works and what it's like to use it. My intention is that after this video, you'll know if you want to try it out or not. You'll either be running away, or you say to yourself, maybe, let's see a real tutorial. In any case, onwards. Here are some games made in Nengi. Along the left we have Sharks.io, which I'll actually play for a moment towards the end of this video. Sharks.io is an IO game, as you may have guessed. That means it's one of those full-screenish browser multiplayer games. A single instance of Sharks can have up to 120 players and 800 AI-controlled fish all swimming around at the same time. This game has a lot of AI in it, so don't take 120 players as some sort of maximum players for Nengi. A simple game can potentially have many more players than that, which is pretty insane when you think about it. Sharks has been played over 1 million times, mostly in the few weeks after it was released. That's about as much real-world testing as Nengi has gotten. The other games are just some screen captures of works in progress. One is a mining game, a real-time race to collect gold through destructible terrain. The space game in the top right is a distant ancestor to Nengi. The game in the lower right is a 2D shooter that I hope to release eventually. In any case, I just show these here to you to suggest that Nengi games don't have to look any particular way. Nengi is just a networking library. Your actual game is usually a combination of Nengi and other libraries. Things such as a 2D renderer, or HTML canvas, or maybe you want to do 3D stuff. If you want physics, you add in your own physics library, or you write it yourself. Combine whatever you want with Nengi. Nengi's just for netcode. Here are some of its features. Nengi is somewhat agnostic, meaning that it can be used for a variety of types of games. It's slightly better for real-time 2D games than anything else, but 3D are also possible. I don't recommend making turn-based games or real-time strategy games. It's better for action games. Action meaning that things move around in real time, so I extend that to mean MMORPGs, shooters, and really a lot of things are action games. I would avoid it for RTS with massive numbers of units, though. A different model is better for that type of game. Nengi is poised to follow an authoritative server model, which is just an inherently more secure style of programming a multiplayer game, but that's a whole topic for a future tutorial. Nengi tries to stay out of your code. As we'll see later in this presentation, you pretty much just create objects like a client or an instance and varying protocols that you attach to some other parts of your code. This is as opposed to being stuck in some sort of engine where you entirely make your game by inheriting classes and things from the engine, and you're restricted in what you can do. Nengi stuff is really just something that you tack onto other logic. Thus it stands a chance at being compatible with libraries, the type of libraries that just try and do one job and do it well. Things like a dedicated physics library or a dedicated renderer. Nengi's high performance? Compared to what? Well, results will vary, but it's something like 50 times more powerful than trying to force Socket.io plus JSON into being a game network library. There's nothing wrong with that, it's just not what Socket.io is optimized for. You can get up to 100 players on a screen. It depends, you can do more than that. You can also end up with a game which could do far fewer than that. Generally, you can do more than that if the players are spread out. That's impressive by indie game standards. That's even impressive by AAA studio standards. Results will vary for sure. You have to program a very specific type of game. Even ignoring netcode, it has to be a very specific type of game to really get very high player counts, such as 300. I've made a game that has 300 players. Sometimes a game like that is not a good game. I'd rather have a better game with fewer players. Let me just say that Nengi's not only about hitting big player counts. I mention it because that's a selling point for some people. But it's totally a valuable library to use in a game that has only 2 players. It's low bandwidth. How low? Well, it's almost as if I designed it to work over a modem. I mean, not while there's 100 players, but while there's, 8 players, like how games used to be. Nengi actually lets you write bits. Yes, bits, not bytes, if you really want. You don't have to get that obsessive. You could just using Nengi at all is going to be a large improvement over JSON or something like that. Nengi also offers a way of culling entities. We'll see that later in the video. But that means that Nengi is a way of knowing what a player needs to receive, and thus cuts out just a lot of stuff that's happening in your game from ever being sent over the network, which is part of what helps its performance so much. We'll see all that in action later. Additional features include entity interpolation. That's the basic kind of smoothing that occurs between snapshots that are coming from the server, results in just perfectly smooth movement. It used to have lag compensation of collisions. It's disabled in the beta release, so I wrote that it's coming back in the future. The form of lag compensation which it possesses is that it records the positions of entities and stores a brief history of where they've all been. This allows you to compensate a collision, such as, well, the classic scenario would be in a first-person shooter. A player with, 500 ping fires their gun. By the time that data reaches the server, whatever they were firing at has moved to some new position, and it's hard to figure out what they've hit. Well, lag compensation allows the server to rewind the positions of all the entities and say, okay, where were they all 500 milliseconds before we received this message? Therefore, where were they at the time that the player fired? What did the player's screen look like? You can answer that question, then you've effectively compensated for lag. It's an advanced feature. It doesn't go in all games. Similarly, it has support for client-side input prediction, which is a related feature. Input prediction is where you apply your keystrokes, your mouse movements, whatever the player input is, you apply them immediately to the simulation on the client side, such that the client feels none of the lag that exists from the controls, in fact, having to reach the server before they affect their character and move them. All these are very game-specific features. You don't put them in every game, but support for them exists in Nengi and will be around in a future version. Nengi's pricing structure varies between free and cheap, or at least I hope you find it to be cheap. It works on a quarterly cycle. If your Nengi related products earn less than $3,000 in a quarter, it's free. If your products earn more than $3,000 in a quarter, you owe a 5% royalty of the revenue in excess of $3,000. Revenue is defined in the license, but it's generally all the game-related revenue, retail sales, microtransactions, ads, subscriptions, anything really. So it poses basically a business question to you of, is it worth it? Would using Nengi increase revenue by more than 5%? Would Nengi raise revenue more than an alternative option? These are hard to answer questions. They're hugely speculative. If your interest in Nengi comes because you have an existing game and the existing game's performance was not what you wanted, its server cost was competing with its income, which is, something that can very easily happen, then you might think that Nengi's the right kind of thing to fix it. And it might be. It really might be. But we don't know. It'll be a risk. You'll just be out your dev time. You'll have to work out a prototype, and we'll see. If you're making a game from scratch, it's even harder to answer because you don't know what you would get to without it, and thus it's hard to say what it adds. The types of things that it adds, though, are usually higher player counts than some sort of other option, usually lower server costs. It's my hope that in the vast majority of cases, the 5% is in fact earning money, meaning to pay 5% of the revenue, you in fact get way more than that. So it's my hope that it's just plainly making money for anybody who can in fact use it. That paired with the fact that you don't pay anything if it doesn't make money, I hope all it does is make people money. That's obviously very idyllic, not going to be true all the time. There's going to be an eternal unknown, which is, will Nengi work? There could be bugs in Nengi. There could be pitfalls, things I didn't know about, things I couldn't have foreseen, some security flaw, or maybe it's just too complicated and you can't get it working in a reasonable amount of development time. That risk, unfortunately, is just all on you. It's up to you, really. I'll make tutorials. I'll try and release little demos and little snippets of games and reduce the risk, hone in on showing what it can do and thus helping you answer this question, but ultimately it's up to you if you try it. So how does nengi work? What is it like to use it? Well, first, allow me to pose another question. What is multiplayer? Multiplayer is essentially shared experience. Players come together in a virtual world and they play a game or just hang out. They expect to see the same game world. They expect to see each other's actions. Often they also see one another via some sort of avatar. So multiplayer is really just about synchronizing the state, whatever really, between all of the players. This is what allows them to share an experience. Sticking to an authoritative server model, nengi offers you two high-level objects for creating that shared experience: the client and the instance. The client is the piece of nengi that you build into the game client itself, for example, the browser side of the game. The instance is the piece of nengi that you build into the game server. After clients are connected to an instance, communication is open and facilitated by some low-level objects called messages and entities. First, let's look at messages. Messages are the most basic object used to communicate via nengi. A message is essentially a collection of properties and their values that can be sent over the network. Conceptually, it's barely more complicated than JSON. Here we have a class representing a message example. It is very simple. It has only one property called text. The only part of this code which is actually nengi is on line 9, where you see the protocol, line 9, 10, and 11. This says basically that if we send this object across the network, all we care about is the property called text, and we're going to send text as a string. Let's see it being used. We create an instance of message example. In this case, we're passing the string greetings to it. And then we send it to a client. Internally, nengi is going to pack this message into a snapshot with anything else the client needs to receive. This could be other messages, it could be fancier things such as entities, which we'll see in a moment. At some point, presumably very soon in your game, the whole snapshot will go out and the client will receive it. Here's how the client's code might look for receiving the message. There are only 6 types of things that nengi can send, and in this case we're looking at messages that come from the server. This specific code shows the nengi way of seeing what type of message we've received. In this case, it's the thing we call message example, and all we're doing with it is logging the text property to the console, which is what we said earlier when we defined it. Presumably, if this was a real game, we'd have something like a switch case or some other similar pattern here to handle all the varying types of messages we've defined in our game and will potentially send. Now, that message was really simple. Here's a complicated message. It's not a real message, it's just a message showing off a bunch of the types that exist in nengi. We see there's some text, there's booleans, there's something up there called armor.copper, presumably an enum, perhaps keyed to a string or an int. We see varying types of numbers, integers, decimals, negative numbers, and then some much fancier things: arrays of numbers, arrays of strings, some sort of object, and even some sort of array of objects. These are all the things you can send in nengi. You don't have to send any of these things. Probably don't want to. You can keep it very simple at first, and you should. I'd also like to note that while you can define varying binary types for these numbers, meaning that you can actually send things as a byte or 2 bytes, you can even send them as fractions of bytes, you don't have to do any of that at first. Simply using the types string, boolean, and number can get you a fully working game. You can then revisit these things later, and if you feel like it, you can optimize specific numbers that get sent very frequently in your game. Most games will be perfectly fine, either with no optimization or just optimizing the most common thing that's sent, which in 2D games is X and Y. But that's a topic for a future tutorial where I'll show exactly how to do that and how to figure out if it's worth doing that to any other parts of your entities. Now let's see a real entity that you might have in a game. The concept of entities and views is one of Nengi's most powerful. Each client that connects to the server, aka the instance, has a view. In a 2D game, this is essentially a rectangle. Nengi can determine whether an entity is visible to the client using this information. Let's see an entity. Here we have an orc, or rather the class definition for one. Orc is pretty simple. It only has X, Y, and HP. The Nengi protocol for orc says that if we were to send orc across the network, we would send its X, Y, and HP, and that all of these things are numbers. This is demonstrating the lazy syntax where you don't write anything in binary, you just call things numbers. Here is the usage. I create the orc, and for some reason I gave it a new position, a random position from 0 to 10,000 for both X and Y. And then I add entity, orc, to the instance. From this point on, the orc will be automatically networked. The instance will analyze the orc's X, Y, and HP, the things we specified in the protocol, for changes every frame, and will communicate those to clients who can see the orc. Pretty good, right? How do the clients see the orc? Well, here's how we set up a view for a client. And this particular client has a view which is set to a rectangle, or specifically an axis-aligned bounding box, centered at 500/500, and its dimensions are 800 by 600. You can see there, half width, half height. That's denoting that it's a centered object as opposed to set to its top left corner. What does this mean? It means the client will receive data about any entity that enters that view. That previous orc I created had a random position. Maybe it's in there, maybe it's not. You may notice that there's some other code around. This particular snippet shows how you might set the view in a real game as a client connects. This specific function here is invoked on connect, which the Nengi instance will call when a player connects, and you can use a function like this to set up the initial state for a player as they connect. There's a similar line, as you can imagine, on disconnect for when they get out. Spawn player character isn't real code, hypothetical code, something that might be in your actual game. But back to the topic of the view, this view is just created and set to a static value here. That would work fine for a game that occurs entirely within that area, but if the game world is bigger and the player travels around, then what you end up doing instead is you move the view within your game's update loop. Most likely, you just keep that view centered on the player. So as the player's X and Y change, you change the client view X and Y. What Nengi can do with this centered view that's traveling along with the player, is it can cull everything else out, aka not include anything else that's outside of the view, and thus we have quite a performance gain, because we're only sending the entities to clients who can see them. Now onto the client side for this particular code. There are 3 types of messages that Nengi can send relating to clients. These are create entity, update entity, and delete entity. You can probably imagine what those mean. Create entity denotes that the client should go ahead and create the client-side version of the entity, which is presumably something graphical. This create entity condition occurs when an entity moves from outside of the client's view to inside of the client's view. This also occurs if an entity simply spawns within the view, like in your server-side code. If you added the entity and it just appears in front of the client, you'll get a create entity here on the game client. Update entity denotes that an entity that was already known has changed. Perhaps its X and Y have changed, denoting movement, or whatever you wrote in the protocol. You can write anything in the protocol. If any of those things change, you'll get it here. Delete entity denotes that the client is being instructed to remove the entity. This can occur because perhaps you removed the entity in your server-side logic. For example, you decided the entity was dead and you called remove entity. Or it could also occur automatically via Nengi if the entity moves too far away from the client and there will be no more updates received for it. It will just tell the client, remove this entity, you can't see it anymore, it's gone. And when it moves back into the view, it'll be recreated. So far we've talked about messages and entities. The message is manual, single-fired method of communication. You define it, create it, and you send it to one or more clients. The entity, on the other hand, was similar. It had a protocol, but it had different usage. The entity was created and added the instance, and it stays around for a while. Any changes that occur to it are automatically sent to clients, depending on whether they're within view or not. Now, commands and local messages are really just more of the same. A command is merely a message sent from the client to the server. So it's the same thing as a message, just going in the other direction. This is how you get the actual player input from the game client to the game server. For example, we might create a command that has our mouse position in it. That might look like a command that has mouse X and mouse Y, both defined as numbers. Or perhaps we might have a command that consists of WASD, all defined as booleans, defining the key state as to whether you were holding W, A, S, or D. And thus, these commands are sent to the server and our game is playable. A local message is a bit of a hybrid. A local message is a message that is added to the instance and is sent based on whether it appears within a client's view. So it has spatial data, it has to have an X and Y on it. So for example, if we were to create a local message called explosion and we add it at 50,50, any client whose view includes 50,50 will end up receiving that local message about the explosion. This is really just a convenient way to send a message to players in an area, which is a very common need when you're networking game. An entire game can be made out of these concepts of entity, message, local message, and command. In fact, you could make a whole game just with message, but it would be pretty tedious, and Nengi's concept of an entity just does a ton of work for you. So now I'm going to play a little bit of Sharks and point out Nengi at work. First thing that occurred as I connected to this server is that the server created an entity for me, and then it sent me a message saying what the ID of that entity was. The client's using that to keep a camera locked on to me as I play. The server on its end has a view that is also locked onto this entity. Every frame it moves that view to whatever position the entity's at, thus this view is always following me. The view is used to decide what to send to me as varying things come on screen, these whale sharks, squids, fish, etc. The client receives create entity with the data for those entities. As they change, they move around, lose hit points, etc. We get entity updates for them. As they get eaten or move off screen, we get delete entities. So that's how pretty much everything we're seeing in the game is networked, almost exclusively via entity. Other things made via messages and local messages are things such as the level ups. I ate enough fish, gained enough experience that I have a level up. I received this data in a message. The way this one in specific works is I just have an enum of all the varying level ups that can be offered. So I probably got some message that's like, oh, you got these 3 options. When you send data back to the server, it's in a message called a command. This command looks something like choose level up, and it'll say like, oh, I'm picking the 3rd option. You can see a local message for the blood effects. Whenever something bites something, there's a bit of blood in the water. Local message was the thing that's only sent to people who can see it. So it's just stuff that's on your own screen. So I think you can start to see how these simple objects allow you to communicate just about everything that could happen in a game. Even this leaderboard up here, I guess another player joined since I started making this video. This leaderboard is just another type of message that I send out once every 2 seconds. It has the names and scores of the top 10 sharks. So that's Nengi at work. If you'd like to try using it, you can begin one of the real tutorials, download the bare bones game template from which all the tutorials, well, most of them begin. Those are going to be at timetocode.com/Nengi. Good luck, have fun,